Hello, Algebra 1. As you can see, I'm still in my casual summer attire. But what we're going to be doing in this lesson is lessons 4 and 5. You're going to be looking at distributions of data and then calculating the MAD, or the mean average deviation. So here we go. First thing you're looking at is a which one doesn't belong. You have 4 different dot plots to look at, so go ahead, answer those questions, and start again when you're ready. You could make an argument for any one of these as to why they don't belong, but the idea here is to start looking at the shapes of the data. That's what we call the distribution. And we're going to put names to these different shapes as we go through here. For activities 2 and 3, coming up in your book, it is going to be a card sort. It is best if you can stop the video right now, complete the card sort, and then come back and continue the video. That'll be best for your learning, but if you're doing this video at home or something, then continue and do the card sort when you come back to class. So do the card sort and have me stamp your work when you're ready. This lesson has some really important stuff in the summary that we need to go through. This is going to give you examples of each type of distribution. The first one we're looking at here is symmetric distribution, and they're showing it to you as a dot plot, a histogram, and as a box plot. Symmetric just means that you could draw a line down your data representation and it would be approximately symmetric. And it might not be perfect, but it's going to be approximately symmetric. Also, if the data does show that it is higher in the middle and lower on the ends, we would call that bell-shaped. It would be symmetric and bell-shaped. It does not have to be bell-shaped in order to be symmetric. The next one that they show you is a skewed distribution, and they're showing it to you as a dot plot, histogram, and box plot. The other thing you want to know is that there's a difference between being skewed right and being skewed left. The examples they give you here are examples of being skewed right. And that's because even though we have lots of data over here on the left, we still have lots of data points on the right, and it'll cause the mean to shift right, or the average to shift to the right or be larger. Right here, this would be an example of something being skewed left. I would highly recommend writing that down and drawing that out. And again, even though we have a lot of data over here on the right, all of these data points here on the left would cause the mean, or the average, to shift left or become lower. These are all examples of a uniform distribution, and basically in a uniform distribution, everything is the same. In a box plot, that means that each section or each fourth is going to be the same. A uniform distribution would also be a symmetric distribution because you could draw a line down the middle and it would be symmetrical. The last type of distribution is called bimodal. Bi means 2, like a bicycle has 2 wheels. And so in a bimodal distribution, you'll have 2 sections that have more common data values. Here we have one towards the lower end, one towards the higher end. On the box plot, you can see it's bimodal because the whiskers are pretty short on both ends, meaning that there's a lot of data. 25% of that data is squished into that narrow range. Be sure that you have notes written down for each of those different types of distributions in your summary, and be able to identify those and name those if you see them. All right, in lesson 5, we are going to be calculating the mean average deviation, or the MAD. You may have done this in previous grades, but the big important thing here is that it's going to show us how variable the data is, or how spread out, or how squished together our data is. So here we go. In activity 1, you're just going to decide if each situation is true or false. So you'll do that and start again when you're ready. But just as a reminder, when they talk about mean, that means the average, and the median means the middle of the data. Okay, to review these a little bit, number 1 would be true. That is how you find the mean or the average. Number 2 is false. The mean would not be 4. The mean would end up being 3.5 if you calculate that out. And that'd be 1 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 6 divided by 8. Number 3 is going to be false. To find the median, it's easiest to put them in order, and then you're looking for that middle number, which in this case would be 5. And number 4 is true. If I write these out in order from the dot plot, my middle two numbers are 3 and 4 because it's an even number of data points. So the average of those two numbers would be 3.5. Next, in activity 2, they're giving you some heart rates of 8 high school students listed in beats per minute. So this is the data they give you. I noticed looking down here, they're going to be talking about quartiles. And so I'm going to put the data in order, and I'm going to write down my 5-number summary. This kind of just helps me remember how to find each of those things. And then once I find them, answering these questions is going to be a lot easier. So go ahead, find your 5-number summary first, and then start again when you're ready. Once you have your 5-number summary, it's easy to go on and answer numbers 1 and 2. Interquartile range here first, or the IQR, sometimes we call it. We find that by taking your quartile 3 number and subtracting your quartile 1 number. So it would be 78.5 minus 75.5, which is going to be 3. Go ahead and answer number 2. Start again when you're ready. All right, once you've answered number 2, you'll see that it's all very evenly distributed. So what that tells us is that there's not a lot of data clumped at the high end or the low end. It's very evenly distributed. Number 3, if the median is 5.8 feet, that just tells us that the middle dolphin that they measured had a length of 5.8 feet. It's not our average, but that's the middle number. Number 4, if the test has 50 questions and the interquartile range is 40 correct responses, that means that there is a lot of variability in these grades. That means that your middle 50% of your data varies by 40 points on the 50-point test. So that's a lot of variability, meaning there's some really high scores, there's some really low scores, and there's a big mix in between. In activity 3, we're going to be calculating the MAD, or the mean average deviation. And we're going to be doing that first by calculating the mean. So go look through your data, find the mean, and start again when you're ready. This table below is going to help us calculate the mean average deviation. So they put our data down for us, and then we're going to fill in our mean. And then the deviation from the mean means that we're going to take our data value and subtract the mean. So it would be 72 minus 76.75, which is going to be negative 4.75. Then the absolute deviation, these is going to be the absolute value of our deviation. That's what those two vertical lines mean, absolute value. And if the number is negative 4.75, the absolute value is going to be 4.75. We're going to make it positive. So we keep going down the table and completing those values, and start again when you're ready. Okay, so you filled in your tables, you figured out how far away each value is from the mean. Now to finally calculate our MAD, or our mean average deviation, or mean absolute deviation, we are going to take all of these numbers and find the mean. So once you do that, that one number you come up with is going to be your MAD, or your mean absolute deviation. All right, the number you should come up with is 2. And what that means is that each of these data points is on average 2 values away from the mean. So the data is pretty clumped together because on average, any high schooler would have a heartbeat that's only 2 heartbeats different from the mean. So this number is going to be a measure of your variability in your data and can tell you how closely clumped or how spread out your data is. We are going to skip numbers 2 and 3 in this section. If you'd like to do them for extra stamps, go ahead. A couple things to make a note of in your summary here is that they give you instructions on how to calculate the mean absolute deviation and how to calculate the IQR, or the interquartile range. So just know that that's there and you can refer to that when you need.